Okay, so hello everybody. I'm Martin Looker. I'm an applications training manager at Silicon Labs. Basically, I have a really great job there. I get to play with our cool tech. I make training videos about it. I do workshops. So really, my role is to try and get people up and running on our technologies as easily as possible. And that's been one of the great things about working with Arduino, because that's kind of their goal, to make things as easy as possible. So today I wanted to talk a bit about the Arduino Nano Matter board that we've developed together, and just try and illustrate in the short time that we've got just how easy it is to get up and running and creating Matter and other applications as well. So before we get into the board, if any of you are not familiar with Matter, one of the reasons why Matter is becoming more popular is because if you think back over the kind of semi-recent history of smart home devices, you've had things that have kind of become siloed, so you've got to have a lot of works with programs. If you're making devices, it can be very hard to choose which ones you want to work with. You may have devices that are pretty much identical, but you need a different SKU for them if you're creating for Amazon versus Google. And of course, that has knock-on effects for consumers. They don't necessarily know which ecosystem they want to use. If they choose one, they may be locked in. It's very difficult to move out. So that's kind of been the historical way things have worked. And really, Matter, for the first time, all those major ecosystem companies have decided to work together on a single standard. Most of the semiconductor companies are on board with this as well. And so basically, it makes things a lot simpler. You can make one device, and it will work in Alexa or Google or Apple or any number of other systems. So that's really what the Matter standard is all about, and is the problem it's seeking to solve. So I think Marta's going to talk a little bit more detail about the Nano Matter.
Yeah, of course.
I'll go over this side.
Yeah, thank you. So yeah, this is the Nano Matter that we developed together with Silicon Labs, and it integrates a really great microcontroller from them, which is the MGM240240S, which basically includes M33 core, as well as Bluetooth connectivity and Matter over Thread. So also Thread and Matter, of course, on top of it. And so this is a really tiny board that has low power capability. You can run multiple connectivity at the same time, and also the good part about it is that you have access to a lot of IOs that are exposed through the external pins and castellated pins. So basically, this is how the board looks. Beyond the microcontroller and the antenna that you need in order to run all the RF, you have castellated pins that are exposing serial communication, word, PWM, and also digital and analog IOs. So you can connect plenty of peripherals to them. And at the same time, you have a USB-C connector that can be used in order to power up the board or program it, and a couple of user push buttons that are super useful when you want to start prototyping and understand if the board is interacting with you correctly. Now I leave you back the stage, Martin.
Okay. So while this board is the Nano Matter board, it is a very flexible board as well. So there are lots of other capabilities that are kind of hidden behind that name. So we just kind of wanted to point a few of those out today. So obviously, it works with Matter 1.4. It's the Matter board. It also has full Bluetooth LE in there as well. So if you're looking to create low-power Bluetooth applications, it's another good board that you can use in that way. And the chip's been designed for low-power use. If you make use of the low-power libraries, you can put the device into sleep modes when you're doing things, and really make that work for you if you're doing battery-powered devices as well. It also has some extra bells and whistles in the hardware. So inside the MG24 chip that's on that board is a AI/ML accelerator in hardware. And what that means is you can do your inferencing on the edge inside that accelerator. It will run more quickly than if you were running it in a core on its own, and hence you can do things more quickly and save power. So that's a really great way to do your AI ML on the edge, especially if you want energy and speed efficiency. We also have for the board supporting Zephyr OS for the Bluetooth. So if you're looking to, it lets you pick the best of both worlds in a way. If you want to work with the simple Arduino IDE with all the capabilities and supporting libraries you have there, you have that option. If you want to go a bit deeper, then you can move over to Zephyr and start working with the board on Zephyr for Bluetooth applications. So here I wanted to get a little bit deeper, perhaps a little bit more technical. So if you connect the board up to the Arduino IDE, we have 28 Matter over Thread example applications here. And they vary from sensors, light bulbs, fans. So this makes it really easy to create an example in just a few clicks, and you can bring that kind of device into your ecosystem and start working on it. And the way you do that, we'll take a quick look at. So if you're not familiar with Arduino, the basic application, the way the applications work in your code is you have a setup function that gets called once at startup. That's where you initialize everything for your application. And then we have this loop function that's called over and over again when your main application's running. And that flows through into the way the Matter examples work as well. They fit within this framework. So in terms of providing you with the APIs to work with Matter, there's kind of two levels here. We have in the Matter header file, we have a Matter object, and that deals with generic things you'll need to do in Matter all the time. And basically, as far as these examples are concerned, they really center around monitoring the device, getting into the Matter network, and potentially removing a device from a Matter network as well if you want to. And then we have a number of objects like the Matter fan that encapsulate the functionality of a device. So by bringing in the Matter fan header, creating a Matter fan object, you've then got access to everything you need to build a Matter fan. And we have similar examples for bulbs, sensors, switches, you know, the whole range of things that you can do. And in Matter, you can combine device types into a single physical device. So by adding a bulb and, say, an occupancy sensor, you can create a single device that will provide and act as those two devices within a single device. So, you know, it's very flexible in the terms of what you can build. So taking a look, so the way we use this is the setup function we use to get the device into a network, and really that involves 3 steps. This first commissioning step is waiting for you to add the device to the network, and that happens over Bluetooth. And what you do is you provide the credentials the device needs to join a thread network over Bluetooth, and you scan a QR code to kick that process off in your ecosystem app. And we'll see that in action in a moment. The next stage is then to wait for the device to join the thread network. And again, we sit here in a loop waiting for this to happen. And then the final thing that we do in all our examples is we make sure that the device is contactable in the Matter network before we leave this function. And this basically means a device has sent a message to that device when it's joined the network. The commissioning only needs to take place once. All the details you need are saved in non-volatile memory. So if you power cycle a device, it will skip this one instantly and pretty quickly work through the joining and the connecting. And all this is kicked off automatically when you call the begin function on the Matter object. So getting a device into your network is really easy. This will output a URL to a QR code when the device starts up to your serial port, so you can put that in a browser, bring the QR code up on screen. So when you're starting out, if you don't have a way to display the QR code, you can pull it out of here, okay? So hopefully it's really easy to get devices into the network, and we've tried to surface that through the Arduino code as well. Once you're in the network, you're ready to do the work. So in the case of a device like the fan, the basic way this works is there's a data model in the fan object, and for a device that you want to control, you want to turn it on and off, you want to change the speed, the loop function is monitoring the settings in that device model. If a setting changes, like the speed, that will be picked up in the code, and you then apply that change to your hardware. You drive the PWM output more frequently, you speed the fan up. So really, this is looking for changes in values regularly and applying them to your hardware. And if you're doing things in the other direction, if you have a sensor or a switch, it basically works in reverse. You monitor the hardware for changes, someone's pressed the switch, you make the change to the device data model that's within the object, and that will cause any notifications to go out from that device to any devices that are monitoring that switch, and then they can take action upon it. So basically what we've tried to do here is encapsulate the functionality of all these common devices into a set of APIs that you can either monitor, read, or you can write to have this go out. So this makes it, so basically the Matter side of things is pretty much done. You can just make use of it. Your main work is then going to be bringing in extra hardware peripherals to either monitor or control, or a combination. So in terms of the Matter fan example that we've seen a bit of the code of, that doesn't actually control any hardware. There's no hardware on the board to control it, but what it will do is it will output the changes you are making to the UART. So one of the things we've been working on in our training examples repository on GitHub is to add a hardware fan, and we've also added an OLED display as well, and we can use this to display the QR code and information about the fan, what speed is it being set to, we can measure the RPM. So this is really an example of how you can take that basic example and bring in actual hardware and control it. So I've got a short video. The first half of this video will show how the commissioning works, bringing a device into the network, and then the second half will show the fan in action. So, and I'm hoping we've got some sound.
Device page.
I guess we don't have any sound on the video. So the red here is showing that the fan is not in a network. And at the moment, on my mobile phone, this happens to be Alexa. I'm going through the process of adding the device. So here I'm saying I want to scan a QR code. I can scan it off the OLED that's displaying the code, and the ecosystem will work through. And this works in a very similar way for Google or Apple or any of the Matter devices. For the Arduino implementation, we're using test certificates in here. So this is why we get this warning here, but you can accept those. So again, this speaks to the openness of Matter, in that you can bring devices in, you can use these test certificates. If you go into production, you'll need to obtain unique certificates from each device from the CSA. And now we can control the fan. So we can control it through an app, turn the power on and off. We can control it with voice commands, and we can also control it with the button. The button will work through a mode if you want local control. And basically, we're driving the RGB LEDs when we measure the speed, and this will change in time depending how fast the fan is spinning. So the speed of the animation. So really, we wanted to create something a bit visual and show how easy this is to do. So if you want to see this in person, visit Arduino booths. We've got a running demo over there. Silicon Labs I'll be putting a video of this onto YouTube where I walk through the creation of this. And we do have other videos on YouTube. Let's flick ahead. So I've got a quick start video that will walk you through setting up the device. We have a couple of project-based videos to create mood lights, occupancy sensors. There are a whole load of examples in the IDE. There's a big user guide on Arduino's website that will walk you through all these steps. And we have a few other boards in addition to the Nano Matter that we support this on. You can find information in the GitHub. So that's kind of it. We've hopefully made it really easy to get up and running, get your devices into Matter, and making it accessible not just to hobbyists and people who want to play with this, but professionally as well. So really, the focus is you can create your basic example, add in what you need very quickly. So you're really focused on adding in your hardware rather than trying to solve the problem of getting Matter working. So I think that's it. Any questions? Okay then.
You were super clear.
Okay, and hopefully on time. We'll see. Okay, thank you everyone.